Hello everyone. Once again, welcome to PM Networking. Hope you all are doing great. Guys, today we are going to discuss IPv6 stateless address auto configuration, that is SLAAC. So in this video, this is actually day 3 of IPv6 series. In this video, you will understand the automatic configuration of IPv6, not through DHCP, but as you know, we have multiple way to configure IPv6 on the interface of networking devices. Like we can configure manually, we can configure through SLAAC, auto config. After that, we have stateful DHCP, we have a stateless DHCP. So we will understand DHCP in next video or maybe in upcoming video. Today we are going to understand SLAAC, stateless auto config address. That is, let me write over here, SLAAC. Okay, SLAAC stands for stateless. Why we call it stateless, that also I will make you understand in this video, don't worry. Stateless address auto configuration. Done. But before starting this topic, you have to understand the multicasting, right? Because routers are going to send some message on multicast address. As you know, in day one, we had discussed the types of IPv6 address. Like if I will talk about again, we have three types of address: unicast, multicast, and anycast. We don't have broadcast in IPv6 address. In unicast, again, we have three types of address, that is global unicast, after that unique local, and then link local. For each types of IPv6 address, there are some reserve bit. Like if I will talk about link local, so for link local, your IP address will always start from FE08. Let me write it over here. We have three types of unicast address. First one is global unicast, and global unicast will always start from 200, 2000, or maybe /3 or 3000 :/3, right? In last day, in day one, we had discussed this, right? It can be first value can be 2 or first value can be 3, because 3 bits is reserved from INA, right? And rest bits are also reserved for the organization. Like if you want to check those things directly, you can visit to www.ina.org. Here you can check the reserve, means global unicast reserve address. So here I am going to click on number resources, and here you want to see IPv6 global unicast allocation. So here you can click on this button, IPv6 global unicast allocation, and here you can see these are the agent of INA, like APNIC, ARIN, right? RIPE, after that APNIC, LACNIC, like this. So you can see the allocation of IP address. All allocation IP address is reserved, right? Is starting from 200, or not 00 is important. The first bits is important. First value will be always 0 or 1, right? So this is the range. This is the range of your global unicast address, that your global unicast address will always start from 2 or 3, but generally it's starting from 2 now. Maybe in future it will start from 3 as well. Okay, after that you have unique local, and unique local IP address will always start from FC or FD. It will be FC00 :/7, because here we have 7 bits reserve, FC, and it can be FD00 /7, because we have 7 bits reserve over here. So see, if you want to see it, first value will be always in the first value will be always F, means all bits is 1, that is reserve. In second value, how many bits is reserve? 3 bits. 1 1 1, and last bit can be 0, it can be 1. So last bit is, if last bit is 0, then it will be FC00. If last bit is 1, then it will be FD. So your unique local address can be a start from FC00 double colon 7, or it can be a start from FD00 double colon 7, right? Rest value can be anything. After that, we have third type of address, that is third type of unicast address, that is link local address. Link local. And if I will talk about the link local address, so here FE, this IP address will always start from FE80, because here we have 10 bits reserve. We have 10 bits reserve and 2 bits are free over here. Okay, and then we have second types of address, that is multicasting. So this is your global unicast, this one is your unique local, and this one is your link local, right? And here also you have seen how IPv6 addresses are reserved, right? So actually first 48 bits are root bits, right? We cannot change first 48 bits in IPv6 address. These are reserved for the root. We have only 16 bits for subnetting, and last 64 bits are for host portion. Now let me talk about the multicast, guys. That is very, very important in IPv6 address. Multicast. So if I will talk about the multicast, what is multicast? Multicast is one to many, and this IP address will always start from FF. From FF. It will be always start from FF. Let me change the color. FF. After that, value can be anything. FF00 double colon 8. We have 8 bits reserved for multicasting. We have 8 bits reserved for multicasting. So this 8 bit can be, and you know there are two more important value, more important multicast address. First one is FE02 double colon 1, this address, and FE02 double colon 2. These two addresses are very important. Like we are going to understand the stateless address auto configuration. Here we are going to understand this address. Actually routers will send message on these two address. So see this address FE, not FE, multicast, it is FF. It is FF. This is a multicast address. Extremely sorry. How it is possible? FF. It will always start from FF. FF02 double colon 1 and FF02 double colon 2. This address FF02 double colon 1 is for all nodes. When router need to send traffic to all nodes, so it will use this IP address. All nodes, and all DHCP enabled interface join this multicast group. Once you will enable, you know, IPv6 address on any interface, that interface will join this multicast group to forward traffic. Like in this topology, here is my topology. Let's say on router number 1 on F0/0, I have enabled IPv6 address. So whenever router need to send any traffic to all user, so we don't have broadcast address in IPv6, so it will forward the traffic on this multicast address. On this multicast address FF02 double colon 1. And when node need to forward traffic to all router, let's say node need to forward traffic to all routers, that time it will use this address. It is for all routers. Done. These two are important multicast address. Now let me make you understand little bit more about the multicast address, guys, because multicast address is very important address. Let's see here. In multicast, I am talking about the first octet, first hex state. Actually, in IPv6 we have 16 bits in each field. In each field we have 16 bits, and we called hex state to one field. Hex state. Okay, so let me talk about the first hex state. In first hex state, first value will be always f, as you know. Second value will be always what? F. That means, let's say first value is my x1, then x2, then x3, then x4. These are 4 bits, 4 hexadecimal character, right? This x value can be x1 to x4, can be 0 to f. These are hexadecimal character, and each value carry how many bits? 4 bits. Okay, so first x1 will be always what? X1 will be always 1. That's why value is f. X2 will be also what? Always, it will be always 1, right? X2. Okay, so that's why here x1 and x2 will be always what? FF. FF. Now the important field is x3. So your x3 is, if I will talk about the x3, so x3 and x4 are used to identify the multicast address. These two value, x3 and x4, is used to identify the multicast address, that it is an which type of multicast address. Like you know, OSPF version 3, OSPF have reserved one multicast address, like EIGRP have also one reserved multicast address, RIP have also one multicast address. Like this, lots of services are there, right? For them one multicast address is reserved. So these two fields, first value and second value, will be always FF in the first hex state, and the last two value represent your multicast address type. Getting my point? So now if x3 value is 0, that means it is an permanent IP address, like IP address of OSPF, like IP address of EIGRP. So it is an permanent NINT. If x3 value is 1, if x3 value is 1, that means it is an temporary IP address. It is an temporary multicasting address. Temporary multicast address. Temporary. Getting my point? So let's say I have an address like FF02. So tell me, this is a multicast address, and here I am seeing double colon 0 slash anything, or 5, let's say. It is an permanent address or it is an temporary address. So if you know the concept, so you can identify that it is an permanent address or it is an temporary IP address. It is an permanent address, and this address is reserved for OSPF. This address is reserved for OSPF version 3. Version 3. Because see, if you will convert this value in binary, your multicast address into binary, so I am talking about the first hex state now. So first value is F, that means all bits is 1. Second, x2 is also F, that means all bits is 1. Now in third, value is 0 or 1. So as I told you, if value is 0 over here, that's why here you are able to see the 0. That means your value, all value over here is 0, and in fourth value is what? 2, means 0 0 1 0. So this value is 0, that means it is an permanent IP address. If this value is 1, let me write one more multicast IPv6 address, that is, let's say FE01 double colon 5. This is an temporary IP address. This is an temporary IP address. So that's why in all routing protocol, multicast address will be from here FF 02. 02 means we have in the third field value is x3 is 0. That means it is an permanent, it is an reserve IP address. And if I will talk about the last x4, so x4 tell us about the scope of IPv6 address. X4 is nothing but x4 is equal to scope. Like x3, on x3 there are only two values is important, that is 0 and 1. 0 and 1 is important. In the same way, x4 have also some important value like 1, 2, it can be 5, 8 and E. These 5 values are important at x4 position. At x4 position, these 4 value. If I will talk about here 1, so 1 means it is a node. Node means node. Node means, let's say you have one computer over here or one server over here. In the server you are running multiple machine virtually, 1, 2 and 3. So these 3 machines need to communicate with each other. These all machines are inside one node, or suppose these are application. These application need to communicate with each other through the multicast address. So they will use this address, this multicast address. So multicast address will be what? Multicast address will be FF. After that, if 0 then permanent, temporary means 1, so address will be 1, and after that fourth position value will be what? 1. So your multicast address will be FF 1, because my application is using temporary IP address, and after that it is not permanent, and after that value will be what? 2, 1. This IP address can be not moved from one node to another node. Getting my point? If I will talk about 2, if x4 position, at this position value is, let's say 2, that means it is a link. It can be limited up to link. Mean traffic can be forwarded on link only. Router cannot forward traffic from one interface to another interface, or we can say segment, or we can say subnet. Segment. Done. If I will talk about the 5, so 5 is your site. 5 is, that means through this IP address, through this multicast address, we can communicate between multiple network inside a organization. It cannot routable on the internet. Done. If I will talk about like this, 8 have also a specific use. 8 is for organization and E is for internet. Done. So these are multicast address. Here FF will be always fixed. If value is 0, that means it is a permanent IP address. If value is 1, that means it is a temporary IP address, right? So 0, after that value can be anything. Let's say 2 and dual colon 5. Like this is a multicast address of OSPF. If I will talk about the REST routing protocol IP address, multicast IP address, like, let me make you understand over here, then I will start the configuration, because this is very important. If I will talk about the RIP version 1, RIP version 2, RIP version 2 uses which multicast address? RIP version 2 uses which multicast address? 224.0.0.9. So RIP is using which multicast address in IPv6 is FF02. This is a permanent, after that dual colon 9. Same like IPv4. Okay, so these 2 bits is reserved. This is 0, means it is a permanent IP address. This will be 2 and dual colon 9. This is the multicast address of RIP. If I will talk about the OSPF, so OSPF uses which address, which IPv4 address multicast, which IPv4 multicast address, 224.0.0.5. So multicast address of OSPF in IPv6 is also FF02 dual colon 5. So see, first hexed value is same in both address. If I will talk about the EIGRP, so EIGRP, and in OSPF we have one more address, that is for DR and BDR, that is 224.0.0.6. So here in OSPF IPv6 we have same multicast address FF02 dual colon 6. If I will talk about the EIGRP, so EIGRP uses what address? 10, 224.0.0.10. So EIGRP in IPv6 is also using what address? FF02 double colon 10, not 10A, because we represent IPv6 address into hexadecimal. In hexadecimal we don't have any character like 10. Okay, now let me take you to the configuration part. Here is my scenario. Okay, before starting this, first of all, let's say here I have one router with some interface. Let's say interface F0/0. This is interface F0/0 of router. Okay, R1. See, by default IPv6 routing is not enabled on router. By default IPv6 routing is not enabled. IPv4 routing is enabled. So it is an IPv6 client. Here even I have configured IPv6 address, that is, let's say 2001 colon. As you can see, I am also starting global unicast address from 2. So 2001 colon DB 8 colon 1234, let's say double colon 1. I have configured this IP address on router number 1, but until and unless I will not enable IPv6 routing, this router will act as a IPv6 client. So to enable IPv6 routing, you need to run command on router config mode. In global config mode, you will run command IPv6 unicast routing. This command. After running this command, router will start sending RA message from their interface. From this interface, it will start sending RA message. After every 200 seconds, it will send one RA message. RA stands for router advertisement. RA means, let me write over here, router advertisement message. Done. In the RA message, router will carry some information. It will carry some information. Let me make you understand that what will be the information inside the RA message of router. Let's say router 1 is sending this RA message. So inside the RA message, there will be information of, the most important information in the RA will be the prefix. Here let's say prefix length is what? /64. This is the IPv6 address of interface. Okay. and router will send this RA message on multicast address. Now tell me on which multicast address router should send this RA message. Why router is sending this RA message? So that client or node can get IP address. DHCP client can get IPv6 address from router number 1, because now router 1 is DHCP server. So that's why it is sending RA message. Now tell me what will be the destination multicast address. If you know the destination multicast address, you can easily answer, because see, here we had discussed that whenever router will send traffic to all node, it will use this multicast address, right? It will use this multicast address. So in the RA, source will be what? Source will be, source can be, 0. Source can be unspecified, like 0.0.0.0 in IPv4. In IPv6 also we have all field value 0 with /128. So that can be also a source. And there will be one type field. In the type field there will be information about which type of message it is. After that, 2, source can be your link local address. Source can be unspecified as well. But destination will be what? That is important. Destination will be F02:1. Means it is for all node. I am sending this to all node. Okay. So source will be link local address, destination will be the multicast address, right, in the RA message. After that, there will be information about the prefix. So prefix is 2001 colon db8 colon 1234 double colon /64, or there will be prefix length information as well. Prefix length, and prefix length will be 64. There will be source MAC address as well. But these are the important information inside the array. Okay. And let's say to router, here is one client, or it can be router also. That router need IPv6 address. So when this client will receive the RA message, it will get what? 64 bits network ID. Yes or no? Prefix value. And as you know, PC can calculate their, client can calculate their UI64. EUI64, right? EUI64 can be created by the client. So client have 64 bits, and it have got 64 bits from router number 1 through RA message. Now it can create a complete IPv6 address, and it will assign that IPv6 address on the interface. Okay. Whenever we are saying we are enabling the IPv6 routing on router start advertising RA message. If you want to see, let me show you practically. Here I am going to configure this router first. Let's say 2001 colon db8 colon 1234 /64. Okay, let's say I am using this IP address here. In this domain, I am using this IP address. So from this network, I will configure one IP address on router number 1. And let's say I am using what network for other interface. Here, let's say I am using 1.1235. So both network are different, yes or no? Okay, now let me take you on router number 1. Here I am going to configure the IP address. Enable config t, and let me set host name as well. So host name is, let's say, R1. Okay, interface F0/0, IPv6 enabled. If you will enable IPv6 like this, if you want to enable IPv6 on interface, you will enable like this. After enabling, this interface will create one link local address. So IPv6 interface brief, you can see the link local address. Done. Now I am capturing this link of router F0/0. See, is router sending any traffic? No. Any RA message? No. Until and unless I will not configure IP routing on router, it will not send any RA message. Let me configure IPv6 address as well. Interface IP interface 0/0 IPv6 address 2001 colon db8 colon 1234 double colon 1/64. I've configured this IP address. So IPv6 interface brief, you can see. But see, is router sending any message, any RA message? No. But once I will enable what? Routing, IPv6 routing, IPv6 unicast routing. After running this command, you can see this router is advertising. This router will start advertising 1. Okay, I have captured, I think, 0/0 interface, and I have configured IP address on which interface. I think my interface is down now. Interface F0/0, say no shutdown. Okay, now it will start advertising what? RA message. You can see the RA message, router advertisement message. Okay, let me open this message and see what are the information inside the RA message. RA message is nothing but ICMP version 6 message. It is a message of ICMP version 6. Okay, inside the ICMP version 6 message, if you will open it, you can see there are prefix information 2001 colon db8 colon 1234 double colon /64. This is my prefix. This is prefix information. After that, there is source MAC address, and in the IP header, this is source MAC address. In the IP header, you can see source IP address is what? Link local address of router 1. If you want to verify, you can verify it. Let me show you. This is link local address of router 1. So IPv6 interface brief. See, source is FE80 FE80 C801 C801 47FF 4047FF FE06 FE060. Done. So source will be always what? Your link local address, and destination is what? Multicast address, that is FF02 double colon 1, and this is a permanent multicast address. Yes or no? This is a reserve multicast address. Okay, so that means whenever PC need or client need a IPv6 address, they need to wait for how much time? For 200 seconds. That is not fair, because see, router is sending RA message after every 200 seconds. So IPv6 interface F0/0. By running this command, you can check. The ND means never discovery. Router advertisement are sent every 200 seconds. ND means never discovery. Here you can see somewhere. Okay, leave. Okay, so it is sending router advertisement RA message after 200 seconds. But let's say if there is one more line over here, host use stateless auto config addresses. Guys, first of all, tell me why we call this type of address as stateless address. Because we don't have any state, we don't have any record. Because this, let's say PC, on the PC, let me configure IPv6 address. What we can run on VPC, here I can say IP auto. See, this is the IPv6 address of PC1. So it have created this IP address with their own UI64. Means no one have record about the IP address of BPC1, that what IP address BPC1 is using. Yes or no? No one have information about this. So that's why we call it stateless, because we don't have a state of IP address that clients are configuring or creating or using. Okay, after that, here, okay, if new PC will come, let me add one new PC over here, or let me do one thing. Let me show you IP over here. So here also you can see IPv6 address is configured. Yes or no? IPv6 address on PC2 is also fine. Here this is link local address and this is the IP address through what? UI 64, and PC1 have also configured it through UI 64. Through UI 64, both have configured IP address through UI. If you have confusion in UI 64, you please watch my day 1 video. In day 1 I had discussed this in detail. Okay, but let's say when a PC will come up, let me don the PC, this PC, and when this PC will come up, this PC have to wait for 300 seconds to get IP address? No, because once you will click on the interface to obtain a IPv6 address, automatically your PC will send one neighbor solicitation message, NS message. Which message? NS message. Here, see, actually in this diagram I think I should use one actual PC. Let me start it, and here is capturing. So when this PC will come up, this PC have sent what? RS, router solicitation message. So when PC will come up, it will send RS, and in the response of RS, router will send what? RA. Means router will send RA in two scenario. First, periodic after every 2 seconds, and one is in response of RS. Whenever PC will come up, it will send one RS message, router solicitation message. See, in the router solicitation message, if you will open this message, here also you can see message is, it is an IPv6, sorry, ICMP version 6 message, and there is no any information. And source IP is unspecified, means source is unspecified, and destination is what? Destination is FF02:2. As I told you that whenever node will send traffic to all router, they will use what multicast address? This multicast address. FF02:2. Whenever node will send traffic to all router, it will use FF02:2. When router will send traffic to all nodes, it will send on which address? On FF02:1. Getting my point? So see, node is sending it on FF02:2. When any router will receive this solicitation message, router solicitation message, they will generate what? RA, router advertisement, and like that this PC will get IP address. Again on this PC, if you will run command, so you can see this PC have IP address. Okay, and router is sending periodic salutation message, never advertisement message as well. In two scenario, router send what? RA message in the response of RS and after every 200 seconds, that is periodic. Done, guys. Now in the same way on other interface of router also I can configure IP address, IPv6 address. Let me configure that. Config T interface F1/0 IPv6 2001 colon DB8 colon 1235 double colon 1/64 IPv6 address. Here I have missed the address command. Done. Now these PC will have also received created one IP address. If you want to verify, you can verify. So you can see link local address. Soon it is going to create the IP address. So that means router interface is done definitely. So let me run nosert command on this interface. Let's say nosert. After running nosert, the router will send RA message from this interface also, and this PC will get IP address. Now you can see this machine have IPv6 address through EUI 64. Done. These are the network part and these are host part. Okay. Hope till here everything is okay, guys. Now try to understand how to configure stateless IP address between routers. Let me close this lab. And now let me open this lab. Let's say this is ISP. Let's say this is ISP or this is customer is. This is nothing, not PE. This is CE. Customer is, and let's say this one is provider edge. Provider edge. Customer need IPv6 address from the provider. So this router will send what? RS. Router salutation. And then PE router will send what? RA. Let me configure it. Here I am going to configure. What is the length of video? Okay, 42 minutes. Config T, and let's say host name is P and interface F0/0. Let's say here I am using which IP address? Any IP address we can use. 192.192 double colon, not from 192. It will be better if you will start from 2001 colon DB8 because this is reserve. 1234 double colon 0/64. Let's say same IP address again I am using here. Okay. So on ISP router, I am going to configure IPv6 address 2001 colon DB8 colon 1234 double colon 1/64. I have configured it over here. Let's say nosert and show IPv6 interface brief. So you can see IP configuration is done. Now on CE router need IP address from the provider edge. So here what command you will run? Okay, here you will run command IPv6 AutoConfig. Hostname CE. Interface F0/0 nosert. And IPv6 AutoConfig. Sorry. Okay, this command we need to configure the authentication, then only it will work. IPv6 address auto config. This is the simple command that you will run on your CE router. But now do you think that this router will get IP address? So IPv6 interface brief? No. This is link local address. Until and unless you will not enable IPv6 routing on ISP router, it will not generate RS. It will not generate RS. So IPv6 interface fast Ethernet 0/0. You can see this router is not generating RS. Yes or no? So what I am going to do here, I am going to enable IPv6 routing. IPv6 unicast routing. And now CE router have IP address. Yes or no? From router number to from ISP router. Now let's say here I have one user. Let me take one VPC over here. Two VPC. Two number of VPC. I have connected one over here and one over here. Oh, before that I need to down the router. I have to off the router. So what I am going to do, I am going to write the configuration. Save the configuration on ISP router and let me save the configuration on CE router. Right. Now I am going to down it. Let me connect it. Need to add interface. Okay. Here also I need to add one interface. Now, if I will configure IP address on PCs, tell me, can PCs communicate with each other? If I am not running IPv6 unicast routing on router number 1. See, router have IP address on the segment which is connected with each other. I am going to configure the LAN interface IP address. Okay. So on router number 1, and here actually I should use here I am going to IPv6 bad command IP. How I can configure IPv6 on the VPC manually? I think there is no option to configure IPv6 address, or maybe there is option but I don't know. So what I am going to do, I can use the real PC over here. But guys, leave, I will make you understand these things in next video. What I am trying to say, that until and unless you will not run IPv6 routing on router will not perform routing. Means PC cannot communicate, this PC cannot communicate with this PC until and unless you will not run IPv6 routing on router number 1. Even reachability is there. If you will put this route in the routing table of router 1 and this network in the routing table of ISP router, then also it will not communicate. Okay. So that's all for today. This was okay. One more concept is there. Let me make you understand that. Let me take access of router number 1. See, this is the stateless address auto configuration. Now on router number C router, I am going to say interface F0/0 and no IPv6 address auto config. I have removed this command. So IPv6 interface brief. Now you can see there is no any address. There is no link local as well. There is no any link local address as well, because you have not enabled IPv6 over here. Interface F0/0. I have enable IPv6 IPv6 enable. Done. Now so IPv6 interface brief. This interface have only link local address. What you can tell to this router that configure one IP address on F0/0, and you can define the network portion, and you can tell to router that take last 64 bits from the link local. This is what? This is EUI64. Host portion of link local address is EUI64. Okay, so let me show you that also. Interface F0/0, and here I am going to say IPv6, and let's say I have knowledge about the network portion, that is 2001 colon db8 colon 1234 double colon /64 and say EUI 64. Like this also we can configure IPv6 address. Their same IP address router will configure on F0/0, which ISP was providing. Because ISP was also providing only host portion, it was creating the complete IPv6 address through EUI. And this time also you have defined network portion, and it is using 64 bits. Done. So IPv6 interface brief. Done. And if I will change the link local address, because it is taking 64 bits from the link local, and now I am going to change the link local address. Say IPv6 address and 12 double colon 1 and link local. Done. Invalid address. Okay, one more thing here. FE80 double colon, and here I am going to say 1. What happened? Double colon 1. Done. I have changed the link local address, so you can see your global unique address will always will also change. So IPv6 interface brief, you can see. Now your last 64 bits is 1 because of link local. So actually your IP address will always take last EUI64 from the link local. Okay, so whatever 64 bits address are there in the link local, that will become last EUI64 for router. Okay, that's all for today. If you have learned something from this video, please hit on like button. If you have not subscribed this channel, please subscribe this channel as well, guys, because I am uploading this type of video every day. So if you are not subscribing, and if you are only watching, so that's not fair. Okay, that's all for today. We will meet soon in next video. Bye bye, guys.